A mouse is set down in an arena it has never been in before. On the only day of its life this will happen, and directly overhead a dark shape begins to grow. It has never been trained on this. It has never in its life met a predator. And before you have finished reading this sentence, the mouse is already flat against the wall, hidden, gone. That is not a coincidence, and it is not quite what most people assume fear actually is. For a long time the working assumption, inside labs and outside them, was some version of a simple rule. An animal or it watches something else get chased, and only then does a shape or a sound or a smell earn the status of threat. Fear, on this account, is built one bad experience at a time. Instinct is the word we reach for afterward, once the learning has already happened, to describe how automatic it looks in hindsight. The mouse in that arena never got the chance to learn anything. And that is exactly the point of the experiment. In 2013, two researchers, Melis Yilmaz and Marcus Meister, published a study engineered visual illusion. Overhead, they projected an expanding black disc, a shape meant to imitate the appearance of an approaching aerial predator, growing the way a hawk grows in your field of view the instant before it reaches you. For every mouse tested, this was the very first time the animal had ever been placed in that arena, and the very first time it had ever seen that stimulus. No training. No prior trial. No chance to learn what a hawk looks like, or what an expanding shadow overhead tends to mean. Worth being precise about what naive means here. These were ordinary lab mice, not animals raised in total darkness or total isolation from every visual experience. What none of them had ever seen, specifically, was this arena and this exact expanding shape. That is a narrower and more honest claim than an animal that has never seen anything, and it is also the claim the experiment actually needed to make its point. The response did not require a lifetime of learning. It required only a first look. The mice did not need the practice. Around 75% of them fled for cover, beginning to move in less than a quarter of a second. The rest went still instead, freezing in place rather than running. Two different strategies, both essentially instantaneous, both delivered by a nervous system that had never once been shown what the shape overhead was for. Marcus Meister later described the behavior itself as, in his words, incredibly robust, something researchers can rely on precisely because it is so specific to this one visual pattern. The specificity runs deeper than shape alone. The same expanding disc, rendered in white instead of black, is far less effective at triggering the response, which is a strange thing for a supposedly primitive alarm to care about, unless the alarm evolved for one particular kind of shadow and no other. There is also a logic to which of the two responses a given mouse chooses, freezing or fleeing, that the researchers themselves point toward. A predator still far off may be a case where staying still and blending into the surroundings is the safer bet. A predator that is closer, with a hiding place within reach, changes the calculation toward the faster option, an outright sprint for cover. Neither strategy needs a lesson. Both come preloaded, weighted by circumstances the mouse has never personally lived through. So maybe the story is simple after all. Maybe fear is not learned. Maybe it is just there from the first day, waiting for the right shape to switch it on. Except that is not quite what the rest of the evidence says, and the complication comes from an idea that goes back to Charles Darwin. Darwin noticed something on his travels that seemed almost too strange to be a real pattern. Animals on remote islands, ones with no history of large land predators, would let him walk right up to them. Birds. Lizards. Creatures that, on a continent, would have bolted the moment a human came within sight. It became known, loosely, as island tameness, and for well over a century it stayed an anecdote rather than a measured finding. In 2014, three researchers, William Cooper, Alexander Pyron, and Theodore Garland, tested it properly. They measured what is called flight initiation distance, the exact gap between a lizard and an approaching person at the moment the lizard finally decides to run, across 66 different lizard species. If fear of a predator were simply hardwired the same way for everyone, distance from the mainland should not have mattered at all. It mattered enormously. The farther a lizard's island sat from the mainland, and the less contact its ancestors had with mammal predators across evolutionary time, the closer a person could walk before the lizard moved even an inch. Their own conclusion was direct. Island tameness, in their own words, is a real phenomenon, not folklore. The same study also found something that keeps this from being a simple story about switching fear off. Bigger lizards still ran sooner. Faster approaching people still closed the gap before the lizard let them, regardless of how isolated that island was. Those two effects held up on their own, independent of distance from the mainland. So the system was not simply broken or absent on remote islands. It was still doing arithmetic, still weighing size and speed the way a threat assessment system should. What had gone missing, specifically, was any built-in flag on the particular animal walking toward it. A human, to a lizard whose lineage had never been hunted by one, registered as an unscored variable, not a known danger. Put the two findings side by side and something more interesting than either one alone comes into view. A mouse that has never seen a hawk still flees from an expanding shadow shaped like one, at full speed, on the very first try. A lizard whose ancestors have not seen a mammal predator in generations does not flee from a human at all, even though a human is, by any reasonable definition, a predator. The word instinct cannot cover both of these outcomes if it is just shorthand for a general alarm that fires at any sign of danger. What is actually hardwired, on this evidence, is far narrower and far older than fear of predators as a category. It is fear of one specific, ancient, and extremely reliable pattern, something expanding rapidly overhead, on a path that ends in contact. That particular piece of geometry has meant the same thing, across an enormous stretch of evolutionary time and an enormous range of species, it fresh in every generation. What is not hardwired, on the same evidence, is the identity of any particular predator. A hawk, a fox, a human walking toward a lizard with no reason yet to fear one, recognizing any specific threat like that has to be built, either across a species' own long history of actually being hunted by it, or across an individual's lifetime of direct experience. Take that history away, the way island isolation does, and the specific fear simply does not show up on its own. The pattern same circuit, and they were not built on the same schedule. Think of it as two very different kinds of alarm living in the same skull. One is a tripwire, tuned to a single, ancient piece of geometry, ready before the animal is even old enough to have opinions about anything. The other is closer to a list, built slowly, one confirmed threat at a time, empty until something fills it in. A creature can inherit the tripwire complete and still receive the list blank. None of this proves that a mouse consciously experiences lacking a trigger that never had reason to install. Those are separate questions that behavior alone cannot settle, and nothing here is offered as an answer to either one. What the evidence does settle is how old, how narrow, and how well engineered this particular piece of hardware is, and that a close relative of it is still installed in you. The researchers behind the Looming disc study noted something specific on this point. The mouse retina and the human retina are, in their own words, really very similar, so many of the circuits that matter. A separate 2024 review in the journal iScience puts the human side of it plainly, stating that faced with a physically looming object, human infants blink and adults flinch, the same reflex family the mouse ran in that arena, on a stimulus that had never once been demonstrated to either of them beforehand. You have almost certainly done a version of this yourself, more than once, without ever deciding to. Something entered the edge of your vision, growing fast, and your body had already moved before you had a story ready to explain why. That is not an overreaction, and it is not a personality trait showing through. It is a very small, very old, very specific piece of software, built for exactly one kind of danger, running at the same speed it has always run, underneath whatever you were actually thinking about at the time. This channel exists for exactly that gap, the place where an animal's wiring turns out to explain something about your own. So here is the distinction worth carrying with you. What you fear on sight, instantly, without a story attached, may be a piece of hardware this old and this specific, doing the one job. A real experience, or never learn to fear at all no matter how much reason you might expect to have, may be telling you something closer to your own history, or your ancestors, than to any fixed program running underneath it. A brief and genuine note. This video describes research on defensive reflexes and threat perception. It is not a claim about animal consciousness, and it is not advice about any specific fear or anxiety a person might be dealing with. Here is the question for the comments. Think of a moment your body reacted for it. What was it, And did the explanation ever actually arrive afterward? And in the next episode, we follow an animal in the moment its group disappears, and look at what isolation itself does to a nervous system that was built, from the start, to expect company. That one is next.